Hi, thank you for joining us. My name is Dr. Kamba. This is the continuation of Series 1, Unit 4 of our tutorial on choice of appropriate model. Remember, in our previous video, we have established that if the order of integration of the variables are I1, then we test for co-integration to know whether we will be using var or VECM. So with all the variables I1, if the variables are tested to be co-integrated, the appropriate model of analysis is VECM, vector error correction model. However, with I1, if they are tested not to be co-integrated, that is, there is no co-integration, the appropriate model of analysis is var. Although there are varying views also on this, there are different rulings too. In fact, I have seen studies in economic literature where researchers have used var when, despite that they have I1 variables all through, and the test of co-integration shows that there is co-integration. However, the general rule is that var is used when the variables are I1 and there is no co-integration, and VECM is used when the variables are I1 but they are co-integrated. Now, what if the variables are all IO? What happens? Okay. Now, I also have the same variables here: inflation, interest rate, exchange rate, asset price, and real sector output. And look at the ADF result at levels for inflation. It is estimated as minus 3.92, and this is the critical value, minus 2.95. So if you look at the absolute, if you take the absolute values, 3.92 is greater than 2.95, suggesting that the calculated value of inflation at level is greater than the critical value at 5%. Therefore, we reject the null hypothesis that inflation is not stationary and accept the alternative hypothesis that inflation is stationary. Note that inflation is stationary at levels for ADF. Since it is stationary at level, there is no need to conduct a test at first difference. So that is the reason for this dash, 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 dash you are seeing here. Then to confirm the ADF test, we also run Philippe-Perron, and this is the result: 10.2 absolute value compare with 2.96, the critical value. You see that the calculated value is greater than the critical value at 5%. So here, ADF shows that inflation is stationary at levels, and this is also confirmed by PP test. Okay, so because inflation is stationary at level, our remark is that inflation is IO. Then for other variables too, you see that interest rate, exchange rate, asset price, and real sector output are stationary all at level. So the remark is that they are all IO. Now, when the variables are all integrated of the same order, and the order of integration is IO, that is, they are stationary at level, this is the ruling. This is the ruling. Okay. When all variables are IO, it means that they are not co-integrated. As such, the appropriate model of analysis is multiple regression model. Remember, if they are all I1 and they are not co-integrated, the appropriate model of analysis is vector autoregressive model. If they are all I1 and they are co-integrated, the appropriate model of analysis is vector error correction model. Now, if they are all IO, it is an indication that they are not even co-integrated, so there is no need for test of co-integration. The appropriate model of analysis in this case is multiple regression model. Therefore, multiple regression model is a short-run model. Because when variables are not co-integrated, it means that they do not have a long-run equilibrium relationship. Now, what if the order of integration is mixed? Some variables IO, others I1. What happened? Okay, take a look at this. We reproduce the table again in this form. So here you see that inflation, we made inflation, interest rate, asset price, real sector output to be integrated of order 1 except exchange rate. So here you see that the calculated value for exchange rate at level is higher than it's higher than the critical value. Okay, the critical value is not shown here, but the critical value is minus 2.95. For ADF, for PP it is minus 2.96. So here 5.41 is greater than, which is the calculated value for exchange rate, is greater than the critical value at 5% for ADF. The same thing here, this one is for PP, at level it is 5.1, which is greater than the critical value at 5%, that is 2.96. Therefore, we say the variable exchange rate is stationary at levels. That is why it is not, the test is not conducted at first difference for both ADF and for PP. So here the order of integration is IO for exchange rate. But for others, you see that they are I1. That is inflation, interest rate, asset price, real sector output. All of them are not stationary at levels. They are only stationary at first difference. Therefore, they are integrated of order 1, while exchange rate is integrated of order 0. So here, we say the variables have mixed order of integration. Some, about 4 are I1, 1 is IO. It could be 3 I1, 2 IO. It could be 2 I1, 3 IO. It could be 1 I1, 4 IO. So what is important here is that they should not be integrated of the same order. As long as one of them is different, that is, one of them is I1, the rest are IO, or one of them is IO, the rest are I1, we say that the variables are integrated of different order. So what is the ruling on this? When the variables are mixed of I1 and IO without I2, the appropriate model of analysis is autoregressive distributed lag model. Remember that there are I1 and IO is just a necessary condition. The sufficient condition is that none of them must be I2, according to Pensaran and Shin, 2001. None of them, the necessary condition for ARDL model is that the order of integration of the variables must be I1 and IO. But the sufficient condition is that none of them must be I2. All right. There are also views that even if the variables are I1 and IO, ARDL model is appropriate without any, if the variables are I1, IO with no variable being I2, ARDL model is appropriate only if the IO variable is not a dependent variable. In other words, there are 3 conditions for ARDL model. The first is that the variables must have mixed order of integration, IO and I1. The second condition is that none of the variables should be I2. Then the third condition is that the dependent variable must be I1. If the dependent variable is IO, there are some views that ARDL model may not necessarily apply. Thank you very much. Don't forget to like, share, and subscribe.